In this video, we are going to use the Pythagorean theorem to determine the slant height of square-based pyramids. We've got one right here, and a cone, which I've got right here. I'm using some software, which is actually kind of fun, called Tinkercad. It's a nice way to kind of visualize and manipulate 3D shapes. So that's what we're looking at here. So what is a slant height? On a cone, and you can see these lines hopefully on the video, the slant height extends from the vertex at the top to any point around the edge of the base. On the square-based pyramid, the slant height, again, is a line that's on any of the faces, and it goes from the vertex at the top to the midpoint of any of the sides. So that's slant height. You can kind of think of it as being on the outside of the shape. The actual height, or the vertical height of the pyramid or cone, is of course from the top to the exact center of the base. So the height is not the same as the slant height. Height is really useful for questions involving volume. Slant height turns out to be more useful for questions involving the surface area of these shapes. So what we're going to kind of investigate here is the relationship between the height and the slant height of cones and pyramids. So let's take a look at this pyramid. What I'm going to do is I'm going to cut out a right triangle slice of this cone. So I'm going to make my cone transparent, and we're going to just take a look here at this right triangle slice that I've cut out. If I rotate it, we can clearly see that that's a right triangle, where the base of the triangle is the radius of the cone. Maybe I can even shuffle that triangle right out of my cone. So the base is the radius of the cone. This leg of the triangle here is the height of the cone, and then the hypotenuse of that triangle is my slant height. And so I could use the Pythagorean theorem. Well, if I know the radius and I know the vertical height, then I could use the Pythagorean theorem to find the slant height. There's a relationship there using Pythagoras that exists between the height and the slant height of cones. And we can do the same thing for my little pyramid here. And again, I'm going to cut out a right triangle slice. What I'm going to do again is I'm going to make this transparent. And then if I rotate it, we can see that that's another right triangle. Again, one leg of the triangle is the height of the pyramid. The base of the triangle, or the other leg, is half of the base of the pyramid, because I'm only going into the center from the edge. And then again, the slant height represents the hypotenuse. So again, I'll just show you that right triangle slice. And again, with that same relationship, a Pythagorean relationship between the height and the slant height of a square-based pyramid. So let's apply that to solving one of these problems. First of all, what is a pyramid? Well, a pyramid takes any shape, any two-dimensional regular shape in the base, and it's going to converge to kind of a single vertex at the top. So here's a square-based pyramid. And that sort of definition shows that a cone is very similar. A cone is, when we make this base a circle, when it has infinite sides, kind of works the same way. So here's my base. Again, it's a square base. And let's say each of those is 8 centimeters. And then I want to figure out that slant height, which again is from the middle of one of the edges up to the vertex. And again, I can look at that vertical height, which extends from the center of the base to the top. And there's my right triangle slice that I've cut out. Maybe it's a little bit strange way to look at it, but there it is. And so that slant height S is what I want to figure out. Let's say that the vertical height of that pyramid is 10 centimeters. So again, I can use Pythagoras. The relationship there is a squared plus b squared equals c squared. In this case, my two legs, I've gone halfway across the square base. So I would have 4. And then my vertical height is 10. And I want to figure out my slant height S. And again, I can just follow order of operations now. So I'm going to square 10 and 4 and sum them together. So S squared would be equal to 116. But I don't want to know S squared, I want to know S. So to get rid of the squared, I'm going to do the inverse operation. The opposite of squaring something is square root. So I'm going to take a square root of both sides. Square and square root just cancel out. So S is going to be equal to the square root of 116. So my slant height rounded to 1 decimal place would be 10.8. And I think my units here are centimeters. So all I really want to do in this short video to show a little visualization of that Pythagorean relationship between the slant height and the height of pyramids and cones, and then just show sort of one application or one example. Okay, thanks for watching.